Right, so I'm live with 52 weeks of AWS, and I'm going to go to my next section, which is CloudFront for the AWS Developer Certification material. And I can get right into it here. And I will share my screen. All right, so CloudFront is a nice utility to play around with because of all the neat things that it can do. And I'm gonna just scroll through here and talk about caching, CloudFront, Elasticache. What are some strategies for doing caching? And to kind of get started with here, the idea with caching is that you're trading the capacity for speed. So speed really is important for a lot of things. And if you're going to serve out the latest news, leaderboard, sell tickets, etc., the speed could be the issue that is going to either make or break what you're doing. And so in computing, the cache is actually a high-speed data storage layer. And the purpose of it is to increase the performance of the data retrieval by reducing the need to access the slower stuff, like spinning disk is going to be much, much slower than a cache that's in memory. You're going from seconds to milliseconds. And so caching is a way of trading the capacity for speed, and it enables you to efficiently reuse things, right? So you can have a slow spinning disk that's really good for storing, terabytes and terabytes of data, but the cache is going to be in a fast access system like RAM or random access memory. So let's look at a few different use cases here for caching. So caching can be applied to a few different layers of technology. So, for example, you could accelerate the retrieval of web content on the client by using HTTP cache control headers. I've actually done this before in a social network that I ran. It wasn't me that came up with the ideas. One of the engineers actually was really creative in helping us solve some problems by using HTTP caching. And boy, it really was a huge win for us because we knew certain routes could be cached. Another one is resolving domain names to IP addresses using Route 53. Another one is accelerating retrieval of web content from web servers to manage web sessions. This could be doing things like CloudFront, Elasticache for Redis, Memcache. Also, you could accelerate the application performance at data access using Elasticache for Redis and Memcache. You could reduce latency for a database query by using Elasticache for Redis. These are all great use cases. And you can also have read-heavy and compute-intensive workloads. In that scenario, you would be able to reduce the latency and IOPS for read-heavy applications or social networking, gaming, things like that. Because a lot of times those are really read-heavy, right? Like a message board. And then compute-intensive workloads. So you could cache things like simulations, for example, or HPC kind of scenarios. Now, when you decide what data to cache, a few things to consider would be the speed and expense, right? So it's generally going to be a lot slower and more expensive to acquire data from a database than from a cache. And so in many scenarios, really the cache is a huge win, right? For the users of your system. You don't want to be looking at a web page that is going to be generated every single time. That's why you want some kind of caching to take place for most websites. And data and access pattern is another one. So determining what to cache is also really important for data and access patterns. And it doesn't make sense to cache data that's changing very, very frequently because the process of creating the cache could be more expensive than reading the cache. Likewise, you don't want to cache data if caching provides no speed or cost advantage. It's just going to make things more complex. Staleness. So really by definition, it's okay to have stale data if you're going to cache it. But if it's not stale in a certain situation, you don't want it to be in the cache, right? Like, so you really do have to be careful about like a stock price. It could be cached for a little bit, but maybe not for like more than a day. So let's talk about how to use CloudFront itself. So when someone goes through to a website or use an application, the request is routed through a bunch of different networks to reach the origin server. And so this could be web pages, images, media files, and it could go through lots of different hops all over the place. And so the network latency itself is a huge component of this, right? So every time you have to go to a new server, you can't speed that up. Like, I mean, these are all different hops that you have to go to. So one of the ways you can get around this is by using a content delivery network or a CDN. And the reason why this is such a huge win is that it is a globally distributed system of caching servers. So you push the data into a location where it can be distributed to the lowest latency access point. And so it's very common for HTML, CSS, JavaScript, image files. These all can be located on the application origin server. And then the CDN will deliver a copy of the content from a cache edge or a point of presence, POP, that provides the fastest delivery to the requester. So CDNs will also deliver dynamic content as well. And this would be unique to the requester, not cacheable. So having a CDN deliver dynamic content also improves application performance and scaling. And the CDN would establish and maintain a secure connection to the requester. And if the CDN is on the same network as the origin, it'd be routing back to the origin to retrieve dynamic content in an accelerated fashion. And so really the content like data, images, text can be ingested and sent back to the origin. And it really takes advantage of this low latency connection and proxy behavior of the POP or the point of presence. So Amazon CloudFront is a CDN that delivers data, video, application programming interfaces or APIs to customers globally with low latency and at high transfer speeds, all within a developer-friendly environment. And CloudFront would integrate with AWS Shield to provide a built-in security against a distributed denial of service or DDoS attack. So that's one of the really good advantages as well of a CDN, not just the speed, but actually increases the security of your application and protects against like a distributed denial of service attack. Also, it integrates with Amazon Simple Storage Service or S3, and also load balancing and EC2. So if you're using any of those services, they'll directly tie into the CloudFront system. And so Amazon CloudFront is highly programmable, and it integrates with Edge to run custom code that's close to the users and customize the user experience. So Amazon CloudFront will deliver your content through a worldwide network of data centers called edge locations. And when a user would request this, basically you're going to serve it out in the edge location that's got the lowest latency. So this is really the huge win of using CloudFront is no matter where you're at in the world, you're going to get the best possible response time. But as objects become less popular, the individual edge locations may remove those to make room for more popular content. For less popular, CloudFront would then have regional edge caches, and those are deployed globally and close to the viewers. A regional edge cache has a larger cache than the individual edge location, so those objects would remain in the cache longer. And so this would help get more of the content closer to the users, and it would reduce the need for CloudFront to go back to the origin server, and it would have really good performance for a viewer. So I've experienced this myself when I've built a global scale social network where we had servers in South America, servers in EU, and it's a very different performance. You can see it when the logs come back and you see the response time of users that are using the caching. So Amazon CloudFront has currently, and it's expanding, a global network of 166 points of presence, so 155 edge locations and 11 regional edge caches in 65 cities across 29 counties to deliver the content that you need and to deliver content to end users with lower latency. Now, how does actually CloudFront work? This is one of the big questions here, is that in a nutshell, you have an application you're hosting on a server. Maybe it's a static website using S3, and you're in Germany and you have a user in France. When that user would access your application and request an object, let's say it's an image file or the DNS system or whatever, it's going to route the request to the CloudFront location that has the best can best serve the request. So this would be typically nearest the CloudFront edge location, and the edge location, CloudFront would check its cache for the requested object. And if the object is in the cache, CloudFront would deliver it immediately to the user. And if the object is not in the cache, then CloudFront would forward the request to the application origin server, and then that would send the object back to the CloudFront edge location. And so then CloudFront would then forward the object back to the user and would add a cache in the edge location for the next time someone requests the object. So really, there's a very sophisticated, mechanism that makes sure that you have very good performance for your cache data. And so when you use CloudFront to distribute the content, you create a distribution to tell CloudFront where you want the content to be delivered and which origin servers to get your files from, and the details about how to track and manage content delivery. There are a couple different ways to do CloudFront distributions. You have web distributions, which are used to serve content over either HTTP or HTTPS. And those would include static content like HTML, CSS, JavaScript. And you also have RTMP distributions, so those are used to serve stream media over Adobe real-time messaging. Also, CloudFront would assign a domain name to your distribution and send your distribution's config to the edge locations. And so a couple of different places to look at if you want to find more information about this would be the documentation for CloudFront distributions and also RTMP distributions. So another thing to be aware of is you can control how long a file would stay in CloudFront cache before you forward it to another request to the origin. And so typically CloudFront would serve a file from an edge until the cache duration you specified. So a file expires, but then after it expires, the next time the edge location gets a user request of the file, CloudFront would then forward the request to the origin server to verify that the cache content contains the latest content of the file. So by default, what this means is that the file will expire after 24 hours. And for web distributions, you can change the behavior in a couple ways. So you can change the cache duration using things like minimum TTL, maximum TTL, default TTL to change the cache duration for an individual file. You can also configure the origin to add a cache control or expires header. So the idea here is that there could be scenarios where you have like the majority of your content is got a very specific configuration, but then you have really popular content where you may actually want to customize the cache control. Now, Amazon S3 transfer acceleration enables fast, easy, and secure transfers of files over long distances between a client and a bucket. And the transfer acceleration would take advantage of the Amazon CloudFront's globally distributed edge location. So basically, as the data is arriving at an edge location, the data is then routed to S3 over an optimized network path. But when you're using transfer acceleration, it will incur additional data transfer charges. So to use the Amazon S3 transfer acceleration, you can see it's just like a one-liner. You just say enable transfer acceleration on my bucket. Your bucket, enable to use enable for your bucket to work with the transfer acceleration. That bucket name has to have a DNS naming requirement, and it can't contain periods. The transfer data to and from the acceleration enabled buckets would have to follow, like essentially like the new endpoint that's created, and also to access it, you would have to actually access that same endpoint that's actually enabled, which would have something in there like bucket name.s3 accelerate Amazon AWS. So what about Elasticache, which is more like application level development? So Elasticache is basically just in-memory key value store, and it sits in between your application and the data store. And so the idea here is that there are many things where you want to have the ability to give your users or some other microservice or middleware sub-millisecond latency and inexpensive access to copies of data. And so most data stores have areas of data that are frequently accessed but not updated that often. And so when you're querying a database, it's important to know it's always going to be slower and more expensive than a key value pair. So I think a really good example of something like this would be if you're building like a recommendation engine and you needed to do initially like a heuristic because you don't have ground truth data, you could actually generate a kind of a collaborative filtering algorithm where you would have every possible combination of different products to recommend to people based on what they've purchased before, and you would then go through and put that into the cache, and then you never would have to generate a recommendation. You would just essentially look inside the cache and say, oh yeah, if you've already had these kinds of purchases, you're similar to this other user, and they have a new purchase you haven't received yet, right? And so that's a very intuitive and fast way to build a recommendation engine without having all the ground truth data where you would need to train a machine learning model. So Amazon Elasticache is a web service that makes it easy to deploy, operate, scale an in-memory data store or cache in the cloud. And what's great about it is that it actually can use many different kinds of architectures. And it can work with a lot of different services as well. So it integrates with EC2, it integrates with RDS, it integrates with Dynamo, and it also works with deployment scenarios like CloudFormation, Beanstalk, OpsWorks. So what it means that it works with CloudFormation is that you then could use things like Amazon CDK, right? The Cloud Development Kit, which is something I'm a fan of. And also in an example architecture, ELB would distribute the load across a bunch of, let's say, EC2 instances. And then inside of there, you could have Elasticache, improving response time, removing database pressure, things like that. So there's a lot of architectural reasons to have cache inside. So what are the benefits of Elasticache? Extreme performance. Really, that's the big thing, is you just get incredible performance because you have sub-millisecond response time and you have end-to-end ability to use really, really responsive servers. The other thing is it's fully managed, so you don't have to worry about like provisioning things, etc. It can actually get it up and running pretty quickly, and also it has service automation for administrative tasks like failure detection, recovery, software patching. There's monitoring that shows you what's going on. And then also it's scalable. So Elasticache can scale out and scale in based on what's happening with your applications. You don't have to overpay for something, for example. And also the write and memory scaling is supported with sharding, and the replicas can actually provide read scaling. So here's an example here of some of the concepts for working with Elasticache. A node is the smallest building block of Elasticache deployment. A node is a fixed size chunk of secure network attached to RAM, and each node would run an instance of either the Memcache caching system or Redis, depending on which engine you want. Elasticache would then support a variety of general purpose compute optimized or memory optimized nodes. A cluster would be a logical grouping of one or more nodes. An endpoint is a unique address that your application uses to connect to Elasticache node or cluster. A shard is a grouping of 1 to 6 Redis nodes. A replication group is a collection of Redis shards with one primary read, write node, and up to 5 secondary read-only replicas. So a cache, in a nutshell, is a component that stores data so that a future request can be served a lot faster. So a hit, you may have heard this before, a cache hit is when the requested information is in the cache, right, and it's current. A cache miss is when somebody requests something that's not in the cache. And so one of the things you have to figure out is a cache hit, cache miss scenario. So basically, when your application receives request for the data, it's first got to see if it's in the cache. If it is in the cache, it just serves it out. If the data doesn't exist in the cache because it's expired, for example, and that's a miss, then you have to go get it from the data store, which could be really slow. And then finally, your application would then write the data received from the store to the cache. So the next time you request it, it'll be fast. Now, there is a cache miss penalty in that each cache miss will result in 3 trips, right? Because you have to send the initial request for the data, you have to query the database for the data, and then you have to update the cache. And so this can cause a real penalty. And so you want to minimize cache misses. So cache expiration is also something that's really complex. In a real world application, like a given page or screen can cache lots of different things like profile data, top news stories, comments. So one strategy is to always have a way of applying a TTL or a time to live in all of your cache keys. And that way you can know when they actually expire. So really, in summary, Elasticache would support 2 open source in-memory caching engines. The first one is Amazon Elasticache for Memcache. This would allow you to do multi-threading. So this allows Memcache to use more CPU cores than Redis. Elasticache is also for Memcache is low maintenance, right? So it's pretty simple. It has easy horizontal scaling as well. So when you use Memcache clusters, you can just add things in and out. So really, that's the Memcache way is kind of simple, and also, it can use all the cores. Now, Redis is a little more complex in that it has the ability to do complex data types. So while Memcache is designed for caching flat strings like flat pages, with Elasticache for Redis, you can do strings, hashes, lists, sets, sorted sets, bitmaps, right? So a little more application level caching. Persistence, also data in Redis has persistence, also high availability. So you can do replication, automatic failover as well. So you could have multi-AZ deployments, also PubSub. So you can do that kind of a pattern as well. So basically, if you have to decide between the engine, really Memcache is when you don't need advanced features, but Redis is more like for an advanced developer. So caching strategies, a couple things to remember here is that an effective caching strategy is probably one of the most important things to consider, and it's going to be different for gaming, web, mobile, etc. So a couple different things to think about. One is that there's a lazy loading strategy, and this would update the cache only when necessary. And so with lazy loading, you have data that'll be read often but written infrequently. So a good example would be a typical web or mobile app that rarely changes. Now, for a write-through strategy, this would be adding data or updates data in the cache whenever the data is written to the database. So a write-through is caching when you have data that's got to be updated in real time. So a good example would be like top 10 game leaderboard or the most popular news stories, right? So it writes it to the primary source of truth, which is the database, and simultaneously writes that to the cache directly. So what are some of the advantages of lazy loading? So only the requested data is cached, right? So this is kind of nice because you don't really put the cache full of data that's not requested, and also the node failures are not fatal, right? So who cares if the node fails? You just replace it with a new empty node. The application keeps functioning, although it's got a little bit of increased latency. And as new request comes in, it just starts to cache it. The advantage, though, is that there is a cache miss penalty. And so you got to do those same 3 trips, and the data can be stale. And so, a good example in Python, for example, is you could build a function that says def get user ID, check the cache, would be record equals cache.getUser. If the record's none, then go to the query and then populate the cache, right? And then return the record. But the advantages of write through, if we take a look at the write through cache, is that the data in the cache is never stale, right? So that's one of the nice things, right? Because every time you do a new write to the database, it will update what's in the cache. The disadvantages, though, is that every time you have to do a new write, you're going to have to write to the cache and the database, which could add some latency. There also is the possibility of missing data. So, like if there's a new data, the node may not contain the data, and it's going to continue to be missing until it's updated in the database. And so, then you have to figure out how to repopulate the cache when the node goes down. Also, unused data. So a lot of times you could be writing data that people don't need, and so you're actually using more resources. And also the cache churn. If you're writing a lot, you're going to be constantly using the cache for no reason other than to write to it. So in a nutshell, there's a bunch of different things to consider with caching, and I think it's good to look at CloudFront, which is for content and for low latency. Elasticache is used in the sense that there's Memcache and Redis, and you have to choose which one depending on what you're doing as an application developer. And then for strategies, right, we've got the write through, which is really effective in the scenario. We have a lot of writes, and then you have the lazy loading, which is the other strategy, which is really common for kind of the other types of scenarios. All right, so that was a lot of content to cover today. What I will cover next week is container services, which is also a really great topic for people that want to know AWS developers certification. All right, see you next week.